From this topic, we move on to easier topics now for some time, and then we get back. Let's start with hardware, logic gates, and circuit design. I'm not going to cover this as you have already done it in O level, as you have already done it in uh, AS level. Okay? Produce truth tables for common logic circuits, including half adders and full adders. We are only going to cover half adder and full adders, and rest is actually completed. Okay? Drive a truth table for a given logic circuits. We have done it. So let's first do half adders and full adders. All right. What are adders? Adders are circuits which add. So if they add, what does that mean? They take 2 bits and add them up. They take 3 bits and add them up. Where do they exist? They exist in arithmetic unit or arithmetic and logic unit. Why? Because they are adding, they are performing a mathematical operation. So all those circuits which are performing mathematical operations, they are in ALU. That's why we call it arithmetic unit, right? So you would have to memorize these shapes. There might be so many other shapes as well. This when it comes to logic, any logic, if it is logic gates logic, if it is circuit logic, if it is your programming logic, many may have many may have different forms of logic. This is one of the logic, which is I believe is the easiest one. If you see, this particular circuit is taking two inputs. This is sum and this is carry. What does that mean? Sum and carry. When we add, you know how to add. When we add 2 bits or 3 bits, let's say this is 1 and 1, 2 in binary. This 0 is sum, this 1 is carry. When we add 1, 1 and 1, becomes 3 in binary. This one is sum, this one is carry. So if we have got two numbers that we are adding, you know how to add these numbers in binary? You know it? Okay. So when we are doing it, we are doing it in columns. When we are doing it in columns, it means that we are taking 2 bits at a time. So when a circuit is adding 2 bits at a time, it is called half adder. And if a circuit is adding 3 bits at a time, it is called full adder. So half adder has got just two inputs because it is adding 2 bits. All right. So it is having two outputs. One is sum, the other one is carry. If you look at this full adder thing, these two, this one is one circuit, this one is another circuit. So it is actually a combination of two half adders. A full adder is a combination of two half adders. See, this exclusive for AND, exclusive for AND, exclusive for AND, and they are being ORed here. Is that clear? So a full adder is a combination of two half adders. These circuits add bits and are found in ALU. They take 2 or 3 inputs and produce 2 outputs. Those which take 2 input are called half adders. and those which take 3 inputs are called full adders, and these are their truth tables. You don't have to actually solve it, you have to just tell. So 0 plus 0 is 0 0, sum is 0. 0 plus 1 is 1, carry is 0. 1 plus 0 is 1, carry is 0. 1 plus 1 is 2, 0 is sum and carry is 1. If it is 3 input, 0 plus 0 is 0, no carry. Acha, mind it, if it is ABC, then we have to make it the C in and this is carry. So we have to make it C out. Cannot keep C on both sides. So we had make it what? C in and C out. So you have to learn it. 0 plus 1 is 2. Sum 0 and 1 carry. 1 plus 0 is 1. This is 2. This is 2. This is 3. Is that clear? So you have to remember this. Alright? If it is 3, it means 1 1. 1 is carry, 1 is sum. Any question? You have to remember these shapes with it. Alright? So they may say that how do we make full adder? So you would have to tell that a full adder is a combination of two half adders. Is all. Is that clear? Very good.